quick little trig simplification that we're going to do now. This actually uses two tricks that are very useful whenever you're doing simplifications. And the first one is to think about trying to factor out any common factors. And have a look at the expression there. Can you see anything that's common? Okay, you can see on the top here, this is actually, I'm just going to rewrite this for you. If you're not happy with the little cube being next to the cos, looks like that. This is cos x cubed. Now you can see that cos x is the common factor. So we're going to factor that out. How many cos x's are in cos x? Well, there's one. And if we take out a cos x from here, I'll have a cos squared x left over. And cot x underneath. Now, at this point, what jumps out at me is this cos squared x. And the reason for that is, if you remember that video with the 3 important trig identities, anytime you see one of those squared trigs, you think about one of those 3 identities. And for this one, I think about this identity. So sine squared theta plus cos squared theta equals 1. Now remember that it doesn't matter what this theta is, it can be anything you want. Here, we've got x. Put that in there. So that's the rule we're going to use. Now what we'll do is we'll rearrange so that we make the cos squared x the subject. Okay, so we can do a substitution. So cos squared x equals 1 take away sine squared x. And what we'll do is sub this in now to our expression. Let's double dot. Oops. So let's write down our expression. So we have cos of x, 1 take away. I'll put another bracket here just so I remember I have to take away what's in that bracket. So I've replaced cos squared x with this here. And we've got cot x underneath. Expand the bracket. Forgot about the x there. That's a very important thing to have. And then we're negating the signs here. And still got cot x underneath. They're going to cancel. So all we're left with, which is quite nice, is the cos x times what's in the bracket, which is just sine squared x over cot x. Now you might think that that's where you finish, but what you need to think about is this cot x. Remember that cot x is actually equal to 1 over tan x. Okay, tan x is sine over cos. And tan x is very often used to eliminate sines and cos, extra sines and coses. It's often used in these type of questions, the same way that cot is. Okay, so if we think about what cot is the reciprocal of tan, so it's upside down, like that. Okay, so that's cot x. So this is actually going to help us with some cancellation to get rid of some of the trig in this question. So I'll just erase this side to finish it off. Oops. So to finish this off now, we've got this expression so far, cos x sine squared x on cot x. Now what I'm going to do to make this a little bit easier to see is I'm going to take this cot x, the denominator, out and multiply, okay, by that 1 on cot x. This is exactly the same because what this does is places the cot x underneath. What it does is it just helps me to see that I have 1 over cot x that I'm interested in. Now remember that cot x is this here, cos x over sine x. If I have 1 over, what that's going to do is it's going to flip this over. So 1 over cot x is actually going to be cot x flipped over, which means that it is in fact tan of x. Let's put the cos x back underneath. And you're going to see a nice cancellation and a nice simplification. So the cos x has gone underneath. I've still got this sine here as well. I'll just remove this so we can fit it in. So to finish off, cos x's cancel out and we've got sine squared x equals times sine x, which is sine cubed x. So simplifying this expression, cos x minus cos cubed x on cot x is actually equal to sine cubed x. Have a look at the video after this as well, which shows you the simple way to do this using the TI Inspire.